Welcome to the Princeton Satellite Systems MATLAB Toolbox Tutorials. Thank you for your interest in Princeton Satellite Systems MATLAB toolboxes. In this video, we are going to demonstrate the different tools available for viewing CAD models. The first step is to open MATLAB. I am using MATLAB version 2014b. The graphics may look different if you are using a different version. I'm assuming that your paths are already set to include the Spacecraft Control Toolbox Professional Edition. I can verify this by typing path to see the path. Here are all of my toolbox paths. We're going to use the CAD model created by a script called Build to Array SC. This generates a satellite with a core bus and two solar arrays which can be rotated independently. We'll load the saved version of the CAD model, which is located in SC Models. Navigate to this folder in the current folder sidebar of MATLAB by double-clicking on each folder until we're in SC Models. Now we see a list of stored models, and if we click on one, the variables in the map file will be displayed in this detail pane at the bottom. We want to load our model into a variable in the workspace, so we're going to type G equals load to array SC. From the data structure displayed, we can see that the satellite has 3 bodies and 34 components. And there's a radius of over 2.5 meters. For a quick view of the satellite, we can pass this model structure to the function drawCAD. Type drawCAD of G. The model is displayed in a plain 3D box with Phong lighting. The triangle edges are shown for clarity. We can rotate the model using the mouse. And for more information about this display function, we can type help drawCAD at the command line. As you can see, the only input to this function is the CAD model, and it does return handles to the patch objects. The toolbox can also display a more photorealistic version of your model using MATLAB's lighting features. For a quick view of your spacecraft using lighting, type Show CAD of G. This will show your model with body rotations applied and Gouraud lighting. This function is in fact a wrapper for the more complex function Draw SC Plan plugin, which can be called in a loop in a simulation. The first thing you may notice in this window, besides the different appearance of the model, are the buttons on the left. This allows you to select and deselect subsystems in the model, which can be grayed out using patch transparency. For a more interactive view of your CAD model, we'll have to use Build CAD Model. This function has an interface with Draw SC Plan plugin, which allows you to hide components and subsystems and explode the model. We'll close this window, close our other window, and run the script that creates the 2-array SC model to see the results. Build to array SC. It will take a few seconds for the model to finish loading. To view the model, click on the Vehicle tab. Note the model metadata displayed in the text box on the left, the list of bodies in the center of the window, and a list of subsystems on the right. There are 3 buttons for opening model visualizations: Show 2D Plan, Show Vehicle, and Show Spacecraft in Orbit. First, let's see the 2D plan. This depicts the list of components in the model using the patches as icons. Although this is a 2D view, you can in fact rotate it. Let's close that window and look at the 3D model. This looks the same as the Show CAD window, except we can interact with it using the controls in the Build CAD Model window. You can click on a subsystem in the list box and display only that subsystem. There's the ACS subsystem, the propulsion subsystem. Click on the All Radio button to go back to the full display. You can use the Open Model slider to explode the model or any of the selected subsystems. You can even view a single component. Click on the Add button to add components one at a time. Notice how the satellite disappears from the view in the 3D window, and now we can use the hierarchical list box to open a body and select a component. This can be very helpful when you are first building a model and need to debug the location or orientation of a component. Those are the reaction wheels. You can also do the inverse, which is to start with the whole spacecraft and subtract individual components. Finally, we can view the spacecraft in orbit. In order for this window to work, you have to have provided an orbit location, or RECI, and an LVLH quaternion via the model metadata. We can see these defined on the left-hand side of the tab. This view also will light the planet using the sun ephemeris, and it will use today's date. When using it in a loop in a simulation, you can specify the actual date of interest. The first thing we notice is that there are two windows open, the orbit view and a control window. Since you have not entered a specific date, the satellite could be in the shadow of the Earth. In order to make it easier to see your model, click on the ambient light checkbox. You can scale the model up and down, zoom in or out, and point the camera at the Earth or the satellite. I'm scaling up my satellite, and there it is. The satellite and the planet are actually drawn in two separate axes, so you can get some very interesting results when rotating with the mouse. But you can also, once you get it set up well, verify the orientation of your satellite. That concludes this video. For more information on our CAD models, see the chapter in the User's Guide and our Build Agile Sat tutorial.